And we can think of this graph as a cylinder, as you can see here. Here's in more simpler terms, with r being the radius and the sides being the height. So from here, we can see that halfway is the radius, and from the sides, it could be the height. And height is dx or dy. And the volume that we will use is going to be pi r squared times height. And when we're trying to find the volume of a area or graph, we can use this equation. So pi's will be the same, the r squared will be the same, but the h is going to be either dx or dy, depending on where it lies off from. So, so this is what you need to know, pretty much, in order to find the volume. Now let's say that you're trying to find the volume about the x-axis. What does that mean? Well, we're simply rotating about the x-axis, and we're trying to find the volume from that axis. So, so pretend this is fx, and we are rotating about the x-axis. So the equation for this would be volume equals from a to b r squared f of x dx, since it's in terms of x. Now for the y function, or the y-axis, it would be rotating around the y-axis, and the radius would be from this point to the y-axis, or from the function to the y-axis. So the equation for this would be volume equals to c d r squared f of y dy, because it's in terms of y. Let's take a look at this question. So it says to find the volume of the solid obtained by rotating the region bounded by the given curve about the specified line. Sketch the region, the solid, and a typical disc or washer. So we have one function and one y value and one x value about the y-axis. So let's try to draw a graph right here. So let's make a t-chart to make sure what we're dealing with. So we had to plug in 3 values to make sure what are we doing. So let's plug in these values. Here we have our values, and now we're going to graph it. So our graph will look something like this. But we still have one problem. We need to find the other x value since we only have one, considering it will be about the x-axis. So we need to find the other x value. So how do we do that? Well, since we have one y value and another y value, we can just set those up equal to each other and we will find the x value. So y will be equal to 0, y equal to the function. Set these up equal to each other. Square them. Get rid of the square root. And 1. As you can see here, the other x value would be x will be equal to 1. So now we have all our information, and let's set up the volume equation. So the radius in this situation is going to be this function. So the square root will cancel out the square. So we will be left with pi from 1 to 5 x minus 1 dx. Now we have to integrate it. Plug in our x values. Well, our final answer will be 8 pi cubed units. Since this is falling, since we are finding the volume, this will be cube units. Let's take a look at this problem. So we have two y functions, and we have to find the volume about the y-axis. So in this situation, we are going to change it in terms of y. So how can we do that? We could easily do this by square rooting. And it's very simple, guys. Now we have to do our other steps. To make a t-chart now, we have to make a t-chart in order to find which would be the outer radius and which would be the inner radius. And now we're going to try to solve this problem using integration. When using the washer method, you always have to use this equation. And what this means is the capital R means you're using the outer radius, and the lowercase r, you're using the inner radius. So in this case, the inner radius would be y equals 2x, and the outer radius would be y equals x squared. As you can see from here, this is more farther away than this function. So we can assume that the square root of y is the outer radius, and y over 2 is the inner radius, dy. We can use simple integration to solve this. And this will be our final answer in terms of cube units.